Hi, welcome to Parametric House. In this tutorial, I wanted to show you how you can make a series of ribs between 2 points. By just changing these 2 points, you can see that this is going to update. This is the total height of the project, which I'm going to explain. We're also going to use graph mappers to design that. So this is going to be the first curve, and we're going to use a separate graph mapper for the second curve. So I'm going to change here the minimum and maximum movement for the first curve, and I'll also have another one for the second curve. So for example, I can use maybe a parabola, change the minimum and maximum movement, and also there is going to be a point attractor which is going to affect the location of the graph mapper, which I'm going to explain, and then at the end we're going to convert that into a thickness and create this final results. So let's get started from scratch and learn this step by step. Okay, let's get started from scratch. What I want to do here is to define 2 points as the starting point of the curve. So I'm going to right click here and set multiple points, and for example I'm going to use shift to say they are in a straight path. Okay, now we have to control the height of the curve, so I'm going to use the curve and primitive line SDL. Let's go to the full name, start. The direction is obviously going to be the Z, unit Z. And the length, we can give this a number slider, which is going to be the total height we're going to have in our project. We can also increase that to more, and let's rename this to height. Okay, so this is the first step we have to take. Okay, now that we have 2 lines, we can select them by going to the set and list item, and by giving it to the list item we can pick the first line and the second line. This is also going to be helpful because when we write the algorithm for the first line, we can just copy paste this for the second one and use it again, because we're going to give 2 different graph mappers for each of these curves. Okay, the first one, we can go to curve and use the divide curve and divide this curve into a series of points. I'm going to use, for example, 100, which is going to be somehow a resolution, so we can name this resolution. And now that we have the points, we want to move them in the Y direction. For this example, you can move them in any direction you want. So let's go to transform and use the move. We can give it Y. And for example, if I just type a single number, all of those points are going to be moved in the Y direction. But because I want to move them in a graph mapper way, non-linear, what I want to do here is to produce a series of numbers and then combine them with a graph mapper, obviously. So the first step is always when you have a series of geometries, for example 101 point, you can go to the set and create a range. This is like the best step you can do. For example, when you divide a curve into 100 point divisions, it's going to give you 101. That's obvious. Let me explain this by explaining that if you have a line and we want it to divide into 2 parts, it's going to give us 3 numbers, right? So whenever we give any number to the count, the points are going to be +1. The exception is when the curve is closed. So for example, if the curve is closed and I want to divide it into 2, obviously I'm going to have 2 points. So remember that for the open curve it's going to be 1 plus that number, and for the closed curve it's going to be the same. Here, when we give it to the range, it's going to produce a series of numbers between, by default it's 0 to 1. We don't want to change this because 0 to 1 is ideal for graph mappers. And when you divide 0 to 1 to this resolution, you can see again it has 101. Let me show you here, 101 numbers. Obviously, if I give that to the Y, it's really small and it's going to start from 0 to 1, which is not really that much. So what I want to do is to convert that into a nonlinear distribution. Okay, to use the graph mapper, you can go to the Params menu, Input, and use the graph mapper component. And for example, if I click here and say graph type sine, I can make this into a nonlinear distribution, which is a sine wave. We can write a function for that, but for now we're going to focus on graph mappers. Okay, we can also combine them. For example, I can say I want to combine two graph mappers, one with the sine wave, another one with the linear. Linear is good. We can simply change the line by playing with these two dots. Okay, after having those two graph mappers combined, because it's between 0 and 1, we can go to the math and use this remap numbers. And remap numbers means scaling those numbers back. It means that we want to remap a series of numbers from a source domain, which by default is 0 to 1, and that's okay because we didn't change the range number. And now we want to bring it to a target domain. Okay, so remember, whenever we want to make a series of numbers from scratch, and with a graph mapper, we use a range, we combine them with graph mapper, and then we scale them with remap numbers. And we also use a construct domain for the target, so we can control the minimum and maximum. So for example, if I say from minus 100 to 100 with 2 decimals, this is going to be move 1 and Control C, Control V, move 2, right? So that's going to control the domain of movement. Now if I give that to the Y, I think it's really too much. So for example, I'm going to put that into maybe minus 30. Okay, now that you can check out the points here, you can see that this is like minus, this is the positive part of the curve, and here we can control it easily. We can have multiple sine waves, and we can play with it like here. Okay, after creating the wave, we can go to the curve and use a spline interpolation and give it to the vertices and just turn off everything to produce that wave-like function. Okay, we can even combine that with a Bezier distribution, which is really cool. Okay, another thing I wanted to control here is to move this wave a little bit up and down. How can we do that? The technique is really simple. Let me explain here. Assume that this is the line, and these are the 100 points we had here. And we had this point attractor moving up and down on the line. So what we can do here is to find the distance between the point attractor and the other points, right? And use that as the graph mapper. So instead of just simply making a range, that point attractor is going to create the parts. So let me just bring this a little bit forward, and first let's make the point attractor curve. You can use the evaluate curve, reparameterize, and we can give it a number between 0 and 1. You can see that we name that T or location. You can see that we can move that up and down. There is also another tool called curve point on curve, which is a slider inside the components, which you can move it up and down. You can right click and, for example, select the mid, but obviously we're going to go with the evaluate curve because now we have the point and we're going to use that as the point attractor. We also had those division points, and now we have to compare them based on distance. We simply go to the vector and select the distance between the points of divisions and the point attractor. Now we have a distance. Instead of range, I'm going to put this down so you have this as the second technique. Now what we have to do is to bring those distances scaled down to 0 and 1 because we wanted to use graph mappers. So I'm going to go to Math, Remap, or Scale the Numbers back. Because the source is not 0 to 1, we have to find it. Just simply use the bounds and give it to your distances. It's going to say it's between 0 to 69, whatever. We give it to the source. And now we have scaled it back to 0 and 1. Okay, now we can give it the graph mapper and remap number part here. So remember that remapping those by giving it the bounds to the source and the target by default 0 to 1, we can get it ready for the graph mapper type, and then we remap it back, and now it's between 0 and 1. We want it to be between a new target. Okay, now that we have that, instead of this one, I'm going to use this one. And this is really cool. You can see that I can change the location based on point attractor. And let's just turn off everything and only turn on the point attractor. And you can see that this is going to affect the location of the graph mapper. So this is how you can control let's go to the non graph mapper with a point attractor. Okay. Now that we have this on the first curve, I'm going to just bring this forward. We can group this. So remember that you can always, I'm going to save this file. If you want to download it, you can always use this one if you want to use without any point attractors, but this one is the most important part. Okay, now that we have this, I'm going to just Control-C, Control-V that, and this time use for the second line. Obviously, we want to use maybe another sine summation. Now that we have those two curves, we can just turn off everything. Remember that we have to turn on the point because we want to change their location. And now we can create, let's bring them inside a curve container. And also another one here. And let's make a tween curve between these two. So let's go to Curve, Spline, Tween Curve, Curve A, Curve B, and the factor is between 0 and 1. Again, we can use the range component or just go to the set range. It's between 0 and 1, and we can give it a step. This is the count of the tween curves. And now you can see that we can design by just using graph mappers, which is really cool. We can even use this parabola. Change the location of the point attractor. Make the first one more sine wave. Change the location. And we will have this series of tween curves here. Okay, at the end, we just want to convert them into a solid. To do that, we can go to Surface and use a bounding box. Give it to here. Because it's going to make a bounding box for all of them, I'm going to right click and make a union box. Let's go to Surface and deconstruct it. So we will have the faces now and pick up the back face. So it's like selecting the face of the back. Let's give this a number slider. Okay, it's 2. And now you can see that it's always going to update based on the curves we're going to produce, especially based on the minimum and maximum it's going to affect. Let's go here and play with this number. You can see that it's sticking to the curve locations. So whenever we change that, it's going to make a back based on a bounding box. Now we can move them a little bit back. So transform, and move in the y direction. This is going to be actually a little bit like the minimum thickness, because it's you can see it's sitting on the curve here. So I'm going to say this is like minimum thickness. And now what we have to do is to make the solids. So I'm going to bring all of these tween curves here, just a little bit back, and project them on this surface. So project, or you can find it from transform, project onto a plane and project all of these. If you give the surface to the plane, it's going to automatically find the plane of that. So it's okay. And now we have them here. Okay, if we loft these together, to loft them 2 by 2, you have to graph that. I usually do that. This is like the best technique I always use, is use the shift key, bring it in one container and see if they are a group of 2. And now you can see it's not, because the zeros are a little bit different. So in addition to grafting, you also have to simplify that. So simplify, simplify, and check that out again. We have a group of 2, and then we can loft it. But I prefer not to loft, because if I bake that, you can see it's making something like this, which is not really that necessary. We just have to make that into a closed surface. So what I usually do is to use a curve and start and end points, and then use a line with 2 points, connect the start to the start, connect the end to the end, and remember that it has to be grafted because we want to make them into groups. Now we can go to curve utility, join, and join everything together. So it's going to be the front curve, use the shift key, the back curves, the lines, and you have to check it out that it always has to be in groups of 4. So again, if you don't see them adding up and there is some zeros here, simplify everything. So you can just simplify the lines. Let me see if this is breaking it. No. But anyway, if you don't see them add up, remember to simplify everything, so you have a group of 4, and now you have those curves closed. And now we can just turn off everything and use Params menu surface container, or just go to surface boundary container. Okay, let's give them a color from custom preview. And I usually use a surface brep edge to see the edges. Okay, so that is going to be the number of divisions we have here. This is going to affect the right and left curves by playing with the graph mappers. That's going to help us explore our design. We can just change the location of the point attractor and get this one. Okay, after producing the surfaces, we can also extrude them. Let's go to surface freeform extrude. I'm going to give this extrude to the preview so we can see it. The direction is obviously in the X direction, and the distance is going to be, let's go back here that we have those 2 lines. Or we can just go and get the start and end points. Okay, we just give that endpoints, for example, which we want to find the distance between these 2 points. Because they are in groups, I'm going to flatten that and pick up 2 of them with a list item, the first one and the second one. And now we can use the vector distance, and we can give that to the x. It's going to be the fit of that. If you want to make it a little bit with a gap, we can give it a multiplication. For example, we can say we want from 10% to 1, but anyway, numbers smaller than 1 is going to be, let's go give this a percentage. So it's the 10% of the total thickness allowed to completely 1. If I go to the rendered mode, and let's change that to black for the normal so you can see the edges. You can see that I have the outputs here. Just turn that off. It's also visible in the shaded mode. And now we can play it by just increasing the number of parts we have. 4 more parts here, and also in the rendered mode, and playing around with the point attractor, the graph mappers. I can also give this to a sine wave, change the location by the point attractor, and also play around with the minimum and maximum, and design this parametric wall inside Grasshopper. Remember that you can download these example files all from our website, parametrichouse.com, and remember to subscribe to our channel, like this video, share it with your friends, and let me know in the comments if any additional examples you need so we can record the tutorial. Thanks for watching. See you next time. Bye.